Let's discuss tri-state buffer and create this tri-state buffer using CircuitVerse. So I search tri-state buffer, you'll see this. You have one input data, one output, and there is a control input. So basically 2 inputs, 1 output. This is called a buffer with active high control input. So we are going to make tri-state buffer active high control. Tri-state buffer active high control. If you go to miscellaneous, you will see this one. Don't try this one. This is the correct one. Now let's have an input A, label A, output Y, label Y, in the control signal. This is also an input, and let's label this as C. And the name is too long, so let's say tri-state buff active high control. Active high control. Now when control is 0, the value of A doesn't matter. Your output should be high Z, high impedance, Z state, or open circuit. But here, unfortunately, CircuitVerse cannot show Z, but this should be high Z, open circuit. See, changing input doesn't change anything in the output. So let's go to the truth table. So let me expand this. More borders. I want this one as well as this one. Yep. So we have A input. Also we have C input, the control input. So you might ask why these cells are going to be adjusted automatically. Because I'm using this code. View code, and this is the code I'm using. If you copy paste this code, then it is going to be the size of cell automatically will fit to the whatever material, whatever is in the cell. So it will be adjusted to the text. Okay, we have input A, we have input control C. We have 2 inputs, So we are going to have 4 combinations of inputs: 0, 1, 0, 1, 2 zeros, 2 ones. Let's get weight of 0 to this one, weight of 2 to the power of 0 to A, weight of 2 to the power of 1 to C. So we have 4 inputs. Our output Y. If C is 0, our output is going to be Z, or high Z, or open circuit. It's not, it's like it doesn't connect to anything. But if, oh, I made a mistake in here. If C is 1, then it's transparent. Y is going to be A, like a buffer. So this is a controlled buffer or tri-state buffer with active high control. So this X is not correct. So when C is 0, doesn't matter. The value of A doesn't matter. You see, if C is 0, the value of A doesn't matter. Output is going to be high Z, high impedance, open circuit, whatever. If C is 1, then if A is 0, Y is 0. If A is 1, Y is 1. Simple. These kind of buffers are, the only logic circuits that you can connect their outputs together. That's a valid statement. Okay, let's check. So now we checked this tri-state buffer with 0 and 1 only, but there's a chance that this is open circuit, and there's a chance that this to be open circuit. In this case, what will happen? So your inputs for A and C are not going to be only 0 and 1. They can be 0, 1, unknown, and open circuit. What will happen in those cases? Let's check. If I write the truth table with 0, 1, X, and Z, then it is going to have 4 by 4, 16 rows. That is not really efficient. So let's try this one. Let's assume this is A. Let's assume this is C input. A can be 0, 1, X, and Z. C can be 0, 1, unknown, and open circuit. Let me fix this. Let's go to border is gone. Let me just select this and this. Okay, and for this one, then Windows key right. Now, this is not a truth table, but you can see the states. This is really nice thing. So if A is 0, so let's try with C. If C is 0, then it doesn't matter what's the value of A. If C is 0, value of A doesn't matter. Output is C. So here we are going to show all 16 possible output. Z. So if C is 0, the value doesn't matter. Even if it's open circuit, your output is going to be high Z. But unfortunately, CircuitVerse doesn't have high Z. It doesn't show high Z value. It's unknown, but high Z is not unknown. It's a completely different thing. Now, if C is 1, if A is 0, output is 0. If A is 1, output is going to be 1. If this is unknown, assume a value of unknown k. Don't assume this is open circuit. If unknown, then we don't know what's the value in the output. So it is going to be unknown. If it's Z or open circuit, so C is 1, A is open circuit. In this case, you might think, okay, the output is going to be Z. Maybe in some technologies, some chips, you can say it is going to be Z, but it's not the case in here. Still, the voltage value in this input is unknown. If it's an open circuit, can result in an unknown value in the output. So the value is going to be unknown. What if C is X in this case? So now this is X, actually open circuit, but X. Really, it doesn't matter what's the value of A. Or open circuit, it doesn't matter what's the value of A. Your output is going to be unknown. Because we don't know the voltage value here. It can be 1, it can be 0, and it can pass everything to the output. So this unknown can be Z, can be 0, can be 1. And let me just fix this. So let me make this. So we can edit the layout. and fix the things and put, you know, you can see here. But the thing is, because CircuitVerse already have it, we don't want to create one. Try set buffer active high control signal. This is it.